Hello viewers, in today's class we are going to discuss one important conceptual integral from definite integrals in which the integrand involves the greatest integer function. So here we have the greatest integer x raised to 4 minus 1 over 3, and here we have x square, and we have to integrate from x is equal to square root of 2 to square root of 3, right? So let us start. So now let us call this integral as I, right? Now here again we have to solve this integral with the help of substitution method, right? So let us take t is equal to x raised to 4 minus 1 over 3, right? So when t is equal to x raised to 4 minus 1 over 3, then obviously 3t is equal to x raised to 4 minus 1, and x raised to 4 is equal to 3t plus 1, right? And x square is equal to 3t plus 1 raised to half, and x is equal to 3t plus 1 raised to 1 over 4, right? So these two expressions will be used here, right? So when we will simplify this integral, then these two expressions will be used, right? Okay, now we are changing the variable x to t, so let us change the limits accordingly, right? So when x is equal to square root of 2, then the value of t is root 2. Here we'll substitute x is equal to root 2. So root 2 raised to 4 minus 1 over 3. So we have here 4 minus 1 over 3, that is 3 over 3, that is 1, right? And when x is equal to square root of 3, then t is square root of 3 raised to 4 minus 1 over 3. Then we have here 9 minus 1 over 3, that is 8 over 3, right? Which can also be written as 2 by 3 in terms of mixed fraction, right? So this limit is approximately equal to 2.66, right? Okay, so now once we have done all this stuff, let us change this integral, right? So now if we differentiate this expression both sides, we have 4x cube dx is equal to 3 dt, right? So differentiating both sides, we have 4x to 3 dx and 3 dt. So now dx can be written as 3 dt over 4x cube, and dx can now be written as 3 dt and 4. For x we can write this expression, so we have 3t plus 1 raised to 1 over 4, and this power will make it 3 over 4, right? Okay, so now we have these expressions, and we can now write this integral I as t is equal to 1 to 8 over 3, because t varies from 1 to 8 over 3. And for x square, this x square, we have 3t plus 1 raised to 1 over 2, and for greatest integer x raised to 4 minus 1 over 3, we have t, and for dx we have 3 dt over 4 times 3t plus 1 raised to 3 over 4, right? Okay, now let us simplify it. So now we can write it, 3 over 4 can be taken here outside the integral sign. So we have 1 to 8 over 3, and here we have greatest integer t, and 3t plus 1 raised to half, and 3t plus 1 raised to 3 over 4. It gets simplified to 3t plus 1 raised to 1 over 4, because half is taken to the denominator. So we have 3 over 4 minus half, that is 4, and here we have 3 minus 2, that is 1 over 4, right? So now we have this integral, right? So now let us see the definition of greatest integer function, which says that see, here we have t is equal to 1, and here we have t is equal to 8 over 3, and this 8 over 3 is approximately 2.66, right? And here we have 1, so between 1 and 2.66 approximately we have the integer 2, right? So between 1 and 8 over 3 we have the integer 2, right? So what we will do, will split this integral as a sum of two integrals, right? So I1 plus I2. So I1, it goes from 1 to 2, right? So here we have 1 to 2, and we have the integrand here, greatest integer t. Here we have dt also, and now we have greatest integer t dt, and 3t plus 1 raised to 1 over 4, right? And the second integral, it goes from 2 to 8 over 3, right? So here we have 3 over 4, and the limits are from 2 to 8 over 3, which is actually 2.66 approximately, right? And we have here greatest integer t dt divided by 3t plus 1 raised to 1 over 4, right? Okay, so now when t lies between 1 and 2, we see that the value of greatest integer t is equal to 1, right? So when t lies between 1 and 2, then the value of greatest integer t is 1, and when t lies between 2 and 8 over 3, that is approximately 2.66, so the value of greatest integer t is equal to 2, right? Okay, so now here we have to take greatest integer t as 1, and here we have to take greatest integer t as 2, right? So now we can rewrite it as 3 over 4, 1 to 2. Here we have 1 dt, and here we have 3t plus 1 raised to 1 over 4, and here we have 3 over 4, 2 to 8 over 3, and for greatest integer t we have 2, and here we have 3t plus 1 raised to 1 over 4, and here we have dt, right? So now we have these two integrals, and we can easily solve these two integrals. So now viewers, in order to calculate this integral, let us consider the indefinite integral dt over 3t plus 1 raised to 1 over 4, right? So if we solve it by method of substitution, we can take y is equal to 3t plus 1, so dy is equal to 3 dt. So now we can write dt is equal to dy over 3, and for 3t plus 1 we have y raised to 1 over 4. So now we have 1 over 3 dy and y raised to 1 over 4. This is 1 over 3 y raised to minus 1 over 4 dy, right? Now by making use of the result x raised to n dx, we have x raised to n plus 1 over n plus 1. So here we have 1 over 3 y raised to minus 1 over 4 plus 1 minus 1 over 4 plus 1. So we have 1 over 3 y raised to 4 minus 1, that is 3 over 4, and here also we have 3 over 4, and this is 4 over 9 and y raised to 3 over 4. Now replacing y by 3t plus 1, we have 4 over 9 and 3t plus 1 raised to 3 over 4, right? So the definite integral of this integral 1 over 3t plus 1 raised to 1 over 4 and 1 over 3t plus 1 raised to 1 over 4 is given by 4 by 9 multiplied 3t plus 1 raised to 3 over 4, right? So now replacing this result here, we have I is equal to 3 over 4, and here we can take out 3 over 4 common. So now we have here 4 over 9 3t plus 1 raised to 3 over 4, and the limits are from 1 to 2, and here we have this 2, taking this 2 outside the integral, and we have 4 over 9 3t plus 1 raised to 3 over 4, and the limits are from 2 to 8 over 3, right? So this is the expression, right? Now what we will do, we'll substitute the value of t and we'll take the difference. So now we can simplify it as 3 over 4. Now taking this factor 4 over 9 and 4 over 9 outside the integral, we have 4 over 9, and inside the brackets we have 3t plus 1 and 3 raised to 4, 3 by 4, and the limits are from 1 to 2, and here we have 2 and 3t plus 1 raised to 3 over 4, and the limits are from 2 to 8 over 3, right? So now this 4 and 4 get cancelled, 3 ones are 3 3s are 9, so we have 1 over 3. And now let us substitute the value of t is equal to 2 here. 3 2s are 6 plus 1 7, so we have 7 raised to 3 over 4 minus, when t is 1, 3 ones are 3 plus 1 4, so we have 4 raised to 3 over 4, right? And here we have t is equal to 8 over 3, so we have 3 and 3 get cancelled, 8 plus 1 9, so 9 raised to 3 over 4 minus, we have t is equal to 2, so 3 2s are 6 plus 1 7, and here we have 7 raised to 3 over 4, right? Okay, so now it is easy to simplify this expression, and we have I is equal to 1 over 3. We have 7 raised to 3 over 4 minus 4 raised to 3 over 4 is 2 raised to 3 over 2, and here we have 2 times 9 raised to 3 over 4 is 3 raised to 3 over 2, and here we have 7 raised to 3 over 4, right? Okay, now we have 1 over 3 and 7 raised to 3 over 4 minus 2 raised to 3 by 2 can be written as square root of 8, and here 3 raised to 3 by 2 can be written as square root of 27, and here we have 7 raised to 3 over 4, right? So now this is 1 over 3, and here we have 7 raised to 3 over 4. Root 8 can be written as 2 root 2, and here we have root 27 can be written as 3 root 3. So we have 2 3s are 6, so we have 6 root 3, and 2 times 7 raised to 3 over 4. Now this term and this term, they are both like terms, so we can subtract them. So we have minus 7 raised to 3 over 4, and we have minus 2 root 2 plus 6 root 3, right? So now we can write this expression as 1 over 3, and this is 6 root 3, this is minus 2 root 2, and here 7 raised to 3 by 4 can be written as the fourth root of 343, right? So viewers, the value of this integral is given by this expression.